Okay, good day. This is Math 140 College Algebra. I'm Professor McCully. This is a lesson 6-2 inverse functions, and we're going to do a part 2. So let's get to it. Today we're going to continue to talk about how functions are one-to-one, and we're going to do that via an algebraic method, whereas we did kind of the eyeball method in the last lesson. And we're going to find inverses again, and we're going to discuss the shape of those things. And we're also going to find the inverse of a non-linear function, limiting its domain if necessary. So just a little bit of quick review here. Talking about two functions. And so again, both the and I'm going to say that this is a parabola just for the sake of argument. This is definitely a function. It does pass a vertical line test. This linear uh, relation is also a function. It passes a vertical line test. But this parabola is not one-to-one in its given shape because it does not pass a horizontal line test, whereas the linear function does. Now we can also talk about other relations. Here is another relation. This relation is not even a function, and it's also not one-to-one. So if it's not a function, it's definitely not going to be one-to-one as well, and that's going to come into play a little bit later. All right. So just to recap, this thing is a function. Oops, let's get the right tool. Did it again. This thing is a function. And is one-to-one. And then this one here is neither a function, and if it's not a function, it's definitely not one-to-one. All right. So in the last lesson, we used a graphing utility to graph given functions and use the horizontal line test to determine if it's one-to-one. And just again, as a quick review here, we're going to go to my y equals and clear all this stuff out. And hit my y equals here. And it was 2x raised to the 1/3 plus 5. And if I go zoom 6 graph on a standard window, we can see that this thing is clearly a function. Any horizontal, or excuse me, vertical line that I would draw in there would, the function would only cross that horizontal vertical line one time. And if I drew in a horizontal line, any horizontal line that I would put through the y-axis would only cross the relation one time as well. All right, that's my visual eyeball test. Okay, so if we want to determine if a function is one-to-one algebraically, this is how we're going to do this. We're going to let A and B be two real numbers. All right, and they have to be distinct. And so then we're going to let f of A equaling to f of B. And so I'll go 3a plus 4 over 5 equal to 3b plus 4 over to 5. All right, and so here I'm going to try and reduce this thing. And we're going to do that where we're going to multiply by 5. And so if I multiply both sides by 5, I'll get 3a plus 4 equals 3b plus 4 because the 5's will cancel. And then we'll subtract 4 from both sides. And then I'll get 3a equals 3b. And then we'll divide both sides by 3. I'll get a equaling to b. And since these are distinct, f is 1-to-1. All right. Now you may say, hey, Mr. McCully, I should be able to do that with just about anything. And I would agree with you, but I am going to show you different. But before I do that, this thing also says if the function is 1-to-1, find the inverse. So I got to do that part as well. And if you recall, the way that we're going to find an inverse is we're going to switch our x and y. So we're going to go x equals 3y plus 4 all over 5. And then we're going to essentially use the same process that I did here, so I'm not going to write it out. But if I multiply both sides by 5, I'll get 5x equals 3y plus 4. If I subtract 4, I'll get 5x minus 4 equals 3y. And then if I flip the whole thing over and divide by 3, I'll get y equals 5x minus 4 all over 3. And therefore, my final answer, f inverse of x, will equal 5x minus 4 all over 3. And we will box that up. Okay, so when will I not get this a equal to b? Well, let's look at this one. And so again, we're going to let a and b be two real numbers. And so I'll go a squared minus, let's do it the correct way here. Let's go f of a equaling to f of b. And so we'll plug a in. So we'll go a squared minus a to the fourth equaling to b squared minus b to the fourth. All right, so how am I going to reduce this one? Well, let's talk about a couple of different, or let's talk about one way that you could do it. And I'm going to say we're going to factor this thing. And we're going to factor using GCF, greatest common factor. All right, so if I do the greatest common factor of both sides, the greatest common factor of a squared, excuse me, a to the fourth is a squared, and that'll leave me 1 minus a squared. And if I factor out a b squared, the greatest common factor of those two terms, of b squared times 1 minus b squared. Now I could factor this more, and I get that. Okay, this is a difference of squares. It could be 1 minus a and 1 plus a, and this could be 1 minus b and 1 plus b. But, all right, we're eventually going to get to the next step after that anyway, so I'm just going to leave it as is because it's not going to affect my outcome. And what I'm going to do instead is I'm going to take the square root of both sides. And if you take the square root of both sides, since we're adding that square root, we have to remember to add, oh, that's really bad. I got to do a better job. R-E-M-E-M-B-E-R, to add plus or minus. All right. So when I take the square root of both sides, I have to do plus or minus square root a squared 1 minus a squared equals plus or minus the square root of b squared 1 minus b squared. And so I can take the square root of a squared. The square root of a squared is just a. Now because of the subtraction here, and square root is essentially an exponent, I cannot distribute exponents across addition and subtraction, so I have to leave that square root of 1 minus a squared. Same thing over here. So I got b squared, or excuse me, plus or minus b square root of 1 minus b squared. All right. Now it's because of this plus or minus on both sides, all right, since there are more than one distinct solution for given distinct solutions given values of A and B, F is not 1, 2, 1. All right. So that is one way to do it. And an easier way, this is a general way, an easier way is just to come up with a value for X that'll give you the same Y. Two values for X that'll give you the same Y. And that'll make it, won't make it 1 to 1. That's just called a counter example. All right. And so as a for instance, if I went, let's see here. I know I had one. Oh, yeah. Just as a counter example. So for this one, if I go f of -1, I'll get -1 squared minus -1 to the fourth. That gives me 0. F of 1 would be 1 squared minus 1 to the fourth, which is also 0. And thus, F is not 1 to 1. All right, so now here's the difference. This method is a generalized method that works for anyone. This method, you might have to hunt and peck a little bit, so it's up to you. All right, so the next thing I want to talk about is graphically, what is an inverse? And so I'm going to use this simple function, and clearly this is linear. And since it is a linear function, it is automatically 1 to 1. And I could find the inverse of that thing. I can go x equals 2y, and then y would equal a half x, and then so my inverse would f inverse of x will be a half x. Let's talk about what this means graphically. All right, let's go to my y equals. I clear this out. I go 2x right here, and then I go a half x like that. I hit graph, and I get these two lines here. Now, graphically, inverses are reflections, and I want to do a better job of, it looks more like an N than an R. Their reflection is about the line y equals x. So if I put in here, in my third one there, my third equation, y equals x, I get this graph here. And if I were to fold my screen along this black line, this red line would line up with the blue line, and the blue line would line up with the red line. And that makes sense because across the line y equals x, what are we doing in the first step? Right here, our first step is to switch x and y. And so inverses are just going to have, or just be the same values except x and y will be switched. So we can find the inverse of a function using a table by switching x and y. So let's talk about, given this function, find the coordinates of the inverse function. So this function on the this black set of values does not have an equation like the ones we had in the past, but it has some points, and we can deal with those points. We can say that this point is negative 2, 0. We can say that this point right here is 1, 0, or excuse me, I did that backwards. It is 0, 1. We can say that this point right here is 1, 2. We can say that this point right here is 4, 3. So if we want to find the inverse function, all we have to do is switch these points. So negative 2, 0 is going to become 0, negative 2, 0, negative 2. The point 1 or 0, 1 is going to become 1, 0, which is right there. And 1, 2 will become 2, 1. And 4, 3 will become 3, 4. Right there. If I connect my dots, a graph that looks like that. And the line y equals x is that line right there. And clearly, if I folded along the dotted red line, we'd have these two pieces would match up, even though my handwriting sucks. Sorry about that. All right, so that's all I got for today. Today, the Marvel fun fact of the day: in Sony's Venom 2018, the Venom symbiote recommends chocolate, and he's looking for chocolate because he needs phenylethylamine, a chemical needed by the symbiotes, and that chemical is also found in brains, which is why he's kind of like a zombie and wants to eat your brain. That's all I got for today, folks. See ya. Bye.